Now in this lecture, we find out the reduction formula for trigonometric functions of product of two functions. So before that, let us first let us first take the sum reduction formula which we have already obtained. So we have obtained the six reduction formulas for sin x, sin to the power nx, cos to the power nx dx, tan to the power nx dx, cot to the power nx dx, sec to the power nx dx, integration of cosec to the power nx dx. So we have already obtained this six reduction formula. Now these are the individual trigonometric reduction formula. Let us find the reduction formula for multiplication of two trigonometric functions. So the question is, find the reduction formula for integration of sine to the power mx into cos to the power nx with respect to x, where m and n are positive integers greater than 2. So we have to find the reduction formula for sine to the integration of sine to the power mx, cos to the power nx with respect to x. So since there are two unknown quantities or two um, values m and n, these m and n are integers over here. So let us find out Imn is equal to this m represent the power of sine and n represent the power of cosine. So Imn is equal to integration of sine to the power mx into cos to the power nx dx. Now we can write down cos to the power nx into two forms, cos to the power n minus 1x into cos x, or we can say that we are breaking cos to the power nx into two parts, cos to the power n minus 1x into cos x. Now it can be written as cos to the power n minus 1x and then sine to the power mx into cos x into one bracket. Why we have written like that? Because we know what is the integration of sine to the power mx into cos x, and then we can use, this is the first function u and this is the second function v, and we can apply the integration by part. So let us write over here the first function is cos to the power n minus 1x, integration of sine to the power mx into cos to the power nx. So we can apply this formula, f of x into f dash of x dx, f of x to the power n, which is equal to f of x whole to the power n plus 1 upon n plus 1. So here, just look here, the derivative of sine x is cosine x. So this is written f dash of x. And so this will become sine to the power mx or t to the power m with respect to t. So what is the integration of t to the power m? It is nothing but t to the power m plus 1 upon m plus 1. So we can write down sine to the power m plus 1 x upon m plus 1 minus the derivative of cos to the power n minus 1 x. This is nothing but cos to the power n minus 1 is, I think this is n minus 1 into cos to the power n minus 2x. Again, derivative of cos x is minus sin x into integration of sine to the power mx cos x is sine to the power m plus 1x upon m plus 1 with respect to x. So this can be written as cos to the power n minus 1x into sine to the power m plus 1x upon m plus 1 plus m minus n minus 1, this n minus 1 upon this 1 upon m plus 1 we are taking outside. This minus and minus will become plus cos to the power n minus 2x into sine to the power m plus 2x dx. This is m plus 1 and this is 1, so it will become sine to the power m plus 2. Let us go ahead. Now we want to break this sine to the power m plus 2 into two part, sine to the power mx and sine square x. Again, we know that what is sine square x? It is nothing but 1 minus cos square x. So we have to just write down that one. 1 minus cos square x, and the remaining part will be same. Now we can open the bracket. So it will be cos to the power n minus 1x into sine m to the power m plus 1x upon m plus 1 plus n minus 1 upon m plus 1 cos to the power n minus 2x into sine mx dx minus this minus, there is a minus sign, so plus and minus will become minus n minus 1 upon m plus 1 cos to the power n minus 2, this n minus 2 and this 2, so n minus 2 plus minus 2 plus 2 into sine to the power mx dx, which can be written as cos to the power n minus x into sine to the power m plus 1x upon m plus 1, n minus 1 upon m plus 1 integration cos to the power n minus 2x into sine to the power mx dx minus n minus 1 upon m plus 1 cos to the power nx sine to the power mx dx, which gives us, this is nothing but imn, and this is nothing but imn minus 2. So now this can be transposed to the left hand side. So we have this minus will become plus. So 1 plus n minus 1 upon m plus 1 im plus 1 imn, which is equal to cos to the power n minus 1x sine m plus 1 sine to the power m plus 1x upon m plus 1 plus n minus 1 upon m plus 1 integration of sine to the power mx cos to the power n minus 2x with respect to x. Now if we take the LCM of this part, so this is m plus 1 plus n minus 1, so plus 1 minus 1 will cancel. This m upon m plus 1, this m plus 1, m plus 1 will cancel, and this is m plus 1. So if we divide whole equation by m plus 1, we have, or we can write down m plus 1, m plus n into imn, which is equal to cos to the power n minus 1x into sine to the power m plus 1x plus n minus 1 into imn minus 2. So therefore, imn equal to sine to the power m plus 1 x into cos to the power n minus 1x upon m plus n plus n minus 1 upon m plus n into imn minus 2. Therefore, imn is equal to sine to the power m plus 1x into cos to the power n minus 1x upon m plus n plus n minus 1 upon m plus n into imn minus 2. Hence, the reduction formula of sine to the power mx into cos to the power nx with respect to x is sine to the power m plus 1 into x into cos to the power n minus 1 x upon m plus n plus n minus 1 upon m plus 1 m plus n into sine to the power integration of sine to the power mx into cos to the power n minus 2 x with respect to x. This is the desired reduction formula for the given integral. Thank you.